Hello friends, welcome to my YouTube channel that is Solidworks tips and tricks. In today's session, we are going to see our next simulation chapter, that is analysis of thin components. In this, I am going to explain you shell element means when and how to use the shell element and what is the benefits of it over solid element in uh, uh, thin sheet metal parts. So I am going to use this pulley for my simulation example. Means if you see here, this is my pulley, and I am going to this pulley is in static analysis. The pulley is supposed to be suppressed by this belt or bed. So because of the belt at the touching face, it will act a pressure on this edge, and that pressure is around zero point 0.2 megapascal. And due to symmetry, I will cut this pulley in half and I will do the simulation. First, I will do one normal procedure to do simulation, that is with the help of a solid element. Then I will do finer element meshing for same solid element, and after that I will go for a shell element and how to apply and where to apply shell element. I will explain that also. So let's say this is my pulley. Now if you go for configuration, I have made one FA pulley. So here it automatically means I considered half pulley due to symmetry, and this is my actually pressure acting area. So for new, I will go for a new study. Here I will go for solid as a name, then okay. Now material is automatically applied in model, so it will carry forward, means it is carry forward here also. No connection, there is no multi-bodies or assemblies are there, so no need of connection. In fixture, I will go for a fixed geometry and I will select this middle face. Okay, then I will select again a fixed geometry. In that advanced option, I will go for a symmetry. Okay, so here I will select this edge, this face, as well as this face, so it will show a preview of whole pulley. So okay, so my fixture is generated. Now for external, I will apply a pressure, selecting this face as a 0.2 megapascal, and okay, direction is fine, so I will go for okay. Now the direction of my pressure force is parallel to my symmetric plane. That is why I can use here symmetric condition. And you can if you don't know how to means where and how to apply symmetry, then you can refer my uh, fourth chapter regarding shrink fit, that wheel and hub assembly. I will give you a link about in my dialog. So for mesh, I will go for a create mesh parameter, curvature base, and whatever default setting is there, and I will go for OK. So it will mesh automatically, and now I will do run. Before that, you need to save your meshing part, means just make a habit of it. Okay, then I will go for a run this study. Study will run accordingly, and it will give me a one way stress and displacement. Okay, so here you can see my study is run automatically, and if you see here, My maximum stress is in the inside layer of my pulley. So that value is around 83 megapascal. Okay. And I want to check what is this outer means outside surface stress value. For that I will go for a prop, and I will select this. Here that value is around 61 megapascal. So for outer face it is around 61 megapascal, and for inner surface it is around 83 megapascal. Remember those values, means I want to use that value to converge it with the shell element results. So now what I will do here, if you see in a mesh, my basic mesh size is if you see my basic mesh size is 3.3 mm, means it's too large. As per the recommendation, the shell element means if you apply a solid element for a thickened part or any sheet metal part whose thickness is too much smaller, in that case you need to apply minimum 2 element across its thickness. Means if you check here for measure, and if you check, okay, wait, I will go for a model. In that I will go for measure, evaluate, measure, layer selection, layer 5 sage. The thickness is 2 mm. So across the thickness you should have minimum two high quality elements. So your basic element size should be minimum is 1. Then you will get at least 2 elements. So for that I need to create, I can copy this study and just increase the density of mesh. So here I will write solid dense and rerun this study with the recreating mesh. So create mesh, and here I will go for a mesh and put element size is 1. So it will automatically go for 1. Now minimum elements are 1, so across thickness 2 elements are there, which will give a very accurate result, and that is a recommended option for your thickened parts. So it will take a little longer time here than your solid study because of the element size and large number of elements. Okay. Now I will save this study. Now you can see the element numbers and element. If you want to see number of elements, you can see Fourier details. The number of elements are now 2,74,000 and ones are around 4 lakhs. So it will took a time around 44 seconds. So for your accurate result, you need to do this final kind of meshing. So I will rerun this study. It also take little bit longer time. Here you can see number of degrees of freedom are around 12 lakhs, means 12 lakh equation are continuously solving. Okay, my results are ready now. Now if you see results, you will see the maximum is around 87 megapascal, and for outside you need to select a probe, and if you select this phase you will come to know what 61 means. Outside there is not that much difference, but inside you will get around 87 megapascal, which is too accurate. Now what we'll do, we will do a same study, and we will do mesh with the shell element uh, for okay, and how much time it will take, we will see that. Here you can see the solver message time is around 0.38 second to solve this to run this analysis, and for meshing it's a different time. So for that, for first I need to create a mid surface. Now what I am going to do, I will mesh a mid surface and run the analysis. Then I will select outside surface and run the analysis, and what is the difference and how it differed with your solid element result, we will see that, and how much time it would take. And for exercise purpose you can go for a inner surface. Now for to create a mid surface, we have a mid surface command in surfacing. I select it, and here I go for finalize. It automatically select create a mid surface. Pink is a one surface, one set of face, and blue is a one set of face, and in between pink and blue there is a mid surface. You can select the position here, and the need surface command is selected, so it automatically create a mid surface. And if you go for a model you will see that as a mid. Now I will go for a new study, and I will select here mid surface. Okay, now I need to suppress this solid body from my analysis, so I will exclude it from my analysis. Okay, so here is my mid surface as a single surface. Now for fixture I have to select again fixed geometry, let this surface. Okay, now again I have to select a symmetry condition, symmetry. Now here I want to select this line, these edges, so I will right click here and go for a select tangency, automatically select all faces. Okay, similarly and bottom. Mm, so this is my selection. Okay, so fixtures conditions are completed successfully. Now for external I will apply some pressure. If you also face this lagging, then just uh, off this preview. It ought to, because it will create a lagging to your system. Here I will go for a 0.2 megapascal, and okay. Here you can see the the fixture and my boundary condition. Now for mesh, I will go for a create mesh. Here no need to go for a too finer, and it also not giving you, means it not take too much time to run the analysis. Let's say we will put here in between curvature base, and yeah, curvature base, and call it is a 5 quality. Okay, I will go for a fine. Okay, yeah, I didn't selected a thickness, means the SolidWorks simulation doesn't know about the thickness. So for that I will select this, and for this surface I will do right click and edit definition. In that, uh, three options came: thin, thick, and composite. Thin is applied when your span to thickness ratio is greater than 20, and it's smaller than 20, you can go for a thick. So here my thickness is 2, so I will go for a 2. You can See here how thickness is going to be applied. Okay, so now this orange surface is basically select you show you that the bottom face of the shell, and this top face is your green. It's shown by green, which is basically top face of shell. Means my selected face is mid face, the above face is the top face, and the orange face is the bottom face. This is just a representation. You can alter that accordingly. Now I will create a mesh for the same. So mesh, create mesh. Okay, within 4 to 5 seconds my mesh is created. Now here you can see the color variation is there. Inside surfaces are with show in orange color, and outside surfaces with the gray color. Basically this is a representation of which surface is which face of your body. Means this orange surface is the inside surface or bottom surface, and this white is the top surface accordingly. Because here you can't get one misses trace for whole body, it shows one misses trace for a top, bottom or mid surface. So this for you, if you want to find bottom surface trace, then as per this color notation, this is my bottom surface, then you have to select this bottom surface. For top you have to select the top surface. I will run the study. Okay, so here if you see on misses trace is around 64, but on which surface is 64 means in solid element my outer surface trace value is 64. So if you click here and go for edit definition, here you can see a new option. Whenever you are going for a shell element, here you can see top. Basically my orange surface is inside one, so which is my bottom. So if you want to see the bottom stresses or inside surface stresses, then I will select the bottom, and here you can see my bottom is inside faces values. So here you can see 78, which is in solid is around 87, and for outside it's around 64. Means you can easily converge that much amount of result with the help of shell element. And what is the time it took to run the analysis, you can see here it's around 0.13 seconds. In solid dense element it around took 36 seconds for the result, and for a mesh it took around 30-32. So it automatically means basically it saves your time uh, for analysis purpose, which is very beneficial with maintaining that results. Now basically you will get a best result at the mid surface of any thickened part. But if you go for, but it is not always possible to go for a mid surface, then at that time you need to go for a top or bottom surface. So we will create a new study. In that I will select the outer faces and do the same analysis. Now I will select outer surface. Okay, now here I don't want mid surface, so I just suppress that mid surface or exclude it from analysis. So I will click right click here and exclude it from the analysis, and I need to convert the solid to my shell element or shell surface. So for that I will click right click and define shell by selected face. I will select this option. Now here I have two options, either I have to select outer surface or inner surface. So I will go for outer one. For inner you can try by your own. You need to select all surface outside the body. Here you can see I have selected all outer surfaces. Now here you have to give a thickness, and now in here offset option is there, which is by default mid surface. Now here you can zoom in out, and here you can see this is my actual this is my selected surface, and this is my thickened surface. This thickened surface should be downward, so I will go for this. It will go outward. I go for this. Here you can see my thickened surface is inside, and here I will go OK. So my solid poly automatically get converted into the shell. You can see here. Now you no need to apply a fixture or faces to these faces. Now you need to apply all around its surface edges. So for that I will go for a fixture. Here component object, nothing is there. Component object, sorry. This. Okay. So fixture I will again the same fixtures. So fix. Now here my create a surface is the outer one, so I will select this. When you go for a inner surface selection, then you need to select this face. So for outer I have selected this face, so I will work on this face. Okay. Now external load, for that I will go for pressure, and I will again apply for this face, so I will select that face. And for inner condition you have to select the inner face, so I will select this. 0.2 megapascal is the value, and I will go for OK. Now again symmetry condition is there, so fixture, again fix geometry. In that uh, in that I will go for advanced symmetric condition, and I will select this edge as because I have selected all outer faces, so I will go for this edge, right click, select tangency. Similarly and bottom, select tangency. But if you go for inner surface, then you need to select an inner edge, and OK. So my boundary conditions are applied. Now I go for a mesh. So create mesh parameter. Again I will go for a fine curvature base. Okay. It also took less time as compared to solid. Okay. Now this time my orange face is outside, which indicates that key my bottom face is this, and layout face is that. If you want to change this allocation, means you need key inside surface should be bottom up, so you can easily select this face which you need to select, then here mesh, right click on mesh, and just go for a flip share element. Select this face, then mesh, flip share. Okay, so let us go. Mm, so this is how you can flip the shell alignment, or you can flip that in your definition, uh, your shell definition point also. So I need to select all faces and to flip all. So select this face, then mesh. just make sure कि your bottom face means you have selected all faces in one direction only. So this is how you can easily uh, flip your shell thickness. Now if you see here, one option is here, render shell thickness in 3D, that will show the thickness according to your body. In this case I have go for a bottom up shell, so my thickness is going to be outside, but in actual case that bottom should be outside because I have selected that as a bottom surface. Okay. Okay, now after mesh we will go for a run. So yeah, run this study. So you see here my one value is a 70, and if I go for a edit definition, for bottom of surface, I'll go for a bottom and okay. So my bottom is around 83. So this is how your results are going to be varied. So for actually if you compare these three results, then you will come to know for a mid surface your values are very much closer to your solid finer element as compared to top or bottom surfaces. You mostly prefer to go for a mid surface, but if it's a complicated shape or you can't create in one single surface, then definitely go for a top or a bottom surface. Okay, so this is it. This is how my solid and shell element are going to be work. Just in shell element you have two methods: first create a mid surface and apply all the studies to your mid surface, or other option is you can go for any top or bottom surface, and there you need to apply the boundary conditions, means define shell by selecting face. That option came. So this is how you can uh, conclude from your shell element. So thank you for watching. If you have any doubts, you can ask me in comments below. Kindly subscribe to my channel, means like, comment and subscribe to my YouTube channel, and also share with your friends. uh, so we'll meet tomorrow for other session. Thank you.